Alright guys, it's time to do the review video for Unit 8. Couple quick things. If you don't know the formulas for circles, the 4 formulas for the angles and the 3 for the segments, that is something definitely you should look at. If you don't know the formulas, you won't be able to pass the test, period. So make sure you're focused and doing something to review for the formulas. I have them memorized because, well, that's the kind of guy I am. So I'm going to go through now and we'll do the review. I would have a calculator out and handy because a lot of these problems, especially on this first page, we're going to be using Pythagorean theorem. I'm going to take a look right here and it says nearest tenth. So if I have to round, I'll be rounding to the 10th. Okay? On number 1, if this is 11.4, then this also over here is 11.4 because that's a right angle. That's one of the things we learned this unit. After that, I'm simply using Pythagorean theorem to find this, which is the radius. X is the diameter, so once I find the radius, I'll just double it. So we have 5.6 squared plus 11.4 squared equals r squared. Alright, so take my calculator and I'll do 5.6, not 5506, 5.6 squared plus 11.4 squared. And I get 161.32, and I'll take the square root of that. And I get 12.7. R equals 12.7. I'm going to double that to get my x, because x was the whole diameter and r was the radius, and so I have 25.4. Next problem. Here, just much more straightforward. That's 4, this is 11. I'm looking for the radius. This is 4 squared plus 11 squared equals x squared. That's 16 plus 121 is 137 equals x squared, and the square root of 137. So let's go shift there, 137, 11.7. We're off to an amazing start. Alright, let's take a look. Find the measure of the arc or angle indicated. This is where knowing the rules comes in handy. If the vertex is on the circle, then the angle is half the arc. So this arc is 122. Now I have a total of 103 plus 122 is 225. I take that away from 360 to get the missing part right here, because the whole circle is 360 degrees, so 360 minus 125, or 225 is 135. So the question mark is 135. Here again, similar idea except for different concept. I'm going to find the arc and then cut it in half. So that's 145 and that's 105. That adds up to 250. That leaves a total of 110 degrees for that right there. So the question mark is half of that. So that's 55. Here, the angle is half the arc. So if the arc is 170, then the angle is 85. So 85 equals 14x plus 1. So 14x equals 84. So x equals 6. And find the measures of the arc or angle indicated. This is 41 degrees, which makes this arc right here 82 degrees. And the rest of the circle is the other arc. So 360 minus 82 is 78. So the question mark here is 78. Here we have an angle inside the circle, not on the center. So we have this arc right here is 50. This is 130. So this arc over here, the angle there was, or the formula there was 130. The angle equals the sum of the arcs divided by 2. So when we do our math here, we get 260 equals 50 plus x. I multiplied both sides by 2, and then x equals 210. All right. Page 2. Number 8. Angle is outside the arc, so 55 equals the big arc, that's the one we don't know, minus the little arc, the one we do know, all over 2. All right. Multiply both sides by 2 and get 110 equals x minus 60. Add 60 to both sides and I get 170 equals x. You can always check your answers on these. You take 170 minus 60, that's 110, and divide 110 in half, and you get 55. All that helps you do is double check your algebra. If you don't know the formula, you've got no shot. Okay, I cannot stress enough. Find a way to know the formulas. Here, we're given the angle outside, so that's 50. I know it's something minus something over 2. Okay, this big arc is the one we don't know. So the big arc is x minus, here we don't know this arc either, but I do know this. If this one is x, then what's left for this one is 360 minus x. And my Algebra 1 teacher always insisted that when I substituted an expression into a formula, I did it inside parentheses. My Algebra 1 teacher was really smart because that way I distribute the negative sign here and I get the problem right, as opposed to not distributing the negative sign and getting the problem wrong. This becomes plus x, and that's all over 2. So this is 100 equals 2x minus 360. 2x equals 460, and x equals 230. Again, you can check your answers here. If that's 230, that leaves only 130 left over here. 230 minus 130 is 100, and 100 divided by 2 is 50. We did it right, yay. Here we have, this is 30, this is 115, this is what we don't know. So even though there's this other little piece over here, that's meaningless to us. We don't need that. We're not looking for that. This is 30 equals x minus 115 all over 2. So we get 60 equals x minus 115, and x equals 175. Easy enough. All right? Let's take a look at these problems at the bottom. Solve for x. Assume that lines which appear to be tangent are tangent. Alright, number 11 is just the product of the pieces. This is 12 times 7, which is 84, equals 6x, and so x equals 14. That was pretty easy. Number 12 is outside times the whole thing equals outside times the whole thing, so 8 times 8 plus x equals 9 times 24. Alright, 9 times 24. Let's make sure we don't get any wrong here. 9 times 24, not 9 times 324. Fat fingers. 9 times 24 is 216. So I have 8 times, go away, 8 plus x equals 216. Now, some of you guys like to distribute. I actually, and you can distribute. There's nothing wrong with that. I actually prefer dividing both sides by 8. It makes the numbers smaller and the math easier. So I have 8 plus x equals 216 divided by 8 is 27. So x equals 19. Okay, let's look over here. We have 27 times 27 plus x equals 45 squared. Let's find out what that is. 45 squared is 2025. Okay, out of curiosity, is that divisible by 27? It is. So when I divide both sides by 27 on this problem, I'm going to get 27 plus x equals 75. Subtract 27 from both sides, and I get x equals 48. Okay. On this one, outside times the whole thing equals outside times the whole thing again. So 9 times 20 equals 10 times 10 plus x. 9 times 20 is 180. I'm going to divide both sides by 10. I get 18 equals 10 plus x. So x equals 8. Alright. Let's take a look down here. These are the problems where you have to figure out the missing pieces before you can figure out the whole thing. So we want the perimeter. Okay, the problem's asking for the perimeter. So that's the sum of all three sides. But on this problem, number 15, we're missing this piece right here, so we can't do it. What we can do is if this is 14, then that is 14. We know that because there are two tangents coming from the same point. If that's 14, all that's left over here for this is 13.1. And if that's 13.1, so is that, which makes this 6.5, which makes this 6.5. And that was the piece that we were missing. So now we have 27.1 plus 19.6 plus this whole side, which is 20.5. Okay, not a bad idea. The number of mistakes that we see in your because you guys won't put problems like this into your calculator, it's staggering. There's nothing wrong with putting this problem into your calculator and checking to make sure that you get 67.2. If you can do that math in your head, congratulations. I'm proud of you, your mom's proud of you, I'm sure your teacher's proud of you, your third grade teacher's probably ecstatic. But on a test, putting it in your calculator to make sure you get it right is a good thing. Okay? Putting 4 times 1 in your calculator to make sure that that's still 4, that's a scary thing. So that's two totally different things. Alright, so this same kind of problem, 2.9, so that's 2.9, which makes that, we have no idea. Alright, so I'm gonna go the other direction this time. If that's 2.9, this is 8, which makes that 8, which makes that 4.7, which makes that 4.7, which makes this 6.4, which makes this 6.4. Okay, so now on this problem we have 11.1 plus 12.7 plus 10.9 plus 9.3. Okay, again, doing this kind of stuff in your calculator, a good idea. What? Slow down. Let's get that out of here. How that happened, I have no idea. Poltergeist is the answer. So we have 11.1 plus 12.7 plus 10.9 plus 9.3 is 44. So our perimeter here is 44. So far, so good. Alright, let's take a look at the 8.0 unit review. Okay, let's make that a little bit bigger. Alright. Okay, so these problems are a little bit different, probably a little bit more complicated, a lot more words and things you may have to draw in for yourself and stuff like that. So please show your work. Lines that appear to be tangent are tangent, and the O is always the center. Okay, so let's see. AD, the diameter is 10. OE is 3. Find the length of BC. So if this is 3, you know, we're really good with right triangles, and when you don't have one, my suggestion is draw one. Okay, so let's draw this triangle in. If the diameter is 10, then this is 5. And this is now a right triangle with sides of 3 and a hypotenuse of 5, which makes BE equal to 4, which makes BC equal to 8. Now I used Pythagorean theorem to figure out that it was 4. I didn't write it down because we've done that Pythagorean triple so many times, but 3 squared plus x squared equals 5 squared is how I got 4. Okay? So not even a lot to do on that problem, just got to know your facts. In the circle below, let's see, again, AD is 30, so that's going to make that 15. And AC is 18, which makes that 9. Find the length of OB, so that's x. So this is x squared plus 9 squared equals 15 squared. Again, this is another Pythagorean triple that we've had a lot of times. X ends up being 12. Number 3. The value of x. If this is 4 and that is 4, then these two chords are congruent. So if that's 8, that's 8. So that chord is 16, so x equals 16. Literally nothing to do mathematically that's more complicated than what you learned in elementary school there. The hard part about this, and this is true for this whole unit, this unit is hard. There are a lot of facts, there are a lot of formulas. You've got to know your stuff. It's not the math or the calculations that's difficult. It's the amount of things, facts, formulas that you have to know and be able to apply. Okay? AB is 20, which makes that 10. AO is 13. We're finding the measure of arc AB, this arc right here. Okay, the way I'm going to do that is I'm going to find the measure of this angle right in here. Okay, that angle is equal to that arc. So if I find the measure of that angle and double it, I'll have the whole arc, and for that I'm going to use trig. So I have the sine, and I named it A. The sine of A equals, you can name it whatever you want, the sine of Franklin, okay, is 10 over 13. We go to my calculator, shift sine. I already changed it to degrees from radians. 10 over 13. 50.3. And then I'm going to double it to get 100.6 is the measure of arc AB. Alright. Did we do everything on that page? We did. Fantastic. Beautiful. On we go. Find the value of x. We've done this problem a lot. This is 42 equals x minus 360 minus x in parentheses over 2. 84 equals 2x minus 360. I distributed there and combined like terms. Add 360 to both sides and I have 2x equals 444. So x equals 222. Find the measure of angle A if CD is 130. So here I'm just labeling things. CB is 80. And BC and DE are the same. So BC is congruent to DE. If this arc, or this chord, and this chord are congruent, then the arcs they intercept are also congruent. So that's also 80. Okay? If that's 80 and that's 80, that's 160. 160 plus 130 is 290, which means that all that's left for this arc right here is 70. Okay? So lots of stuff to plug in, but the measure of angle A is going to be equal to the big arc, 130, minus the little arc, 70, all over 2. 130 minus 70 is 60. 60 divided by 2 is 30. The measure of angle A is 30. Let's take a look here. And again, this is just knowing the formula. This is a lot like the quiz, a lot like the daily check. We see these problems over and over again. Okay, 72 equals 212. 212, that is god-awful. 212 degrees is the boiling point of water. Cross-curricular teaching, and you're welcome. Over 2, 144 equals 212. Minus x, what am I doing? I'm saying one thing and not writing it. 212 minus x. I'm going to subtract 212 from both sides. I'm going to check this one in my calculator just to make sure I get the calculation correct. 144 minus 212 is negative 68. So negative 68 equals negative x, which means x equals 68. Find the value of x. We're going to use this 43 to determine this angle over here. So this is 137. They have to add up to 180 because of what we learned in the second week of school with supplementary lines and linear pairs. So then I have 137 equals 89 plus x over 2, and you get, let's make sure we do this one right also, some of these numbers. Tough to plus them sometimes, kids. 137 times 2 is going to give me 274, and then I'm going to subtract 89 from both sides. Okay, so 274, and then I get 185. X equals 185, just so you can see what I did there. Multiplied both sides by 2, so this is 274 equals 89 plus x, then I subtracted 89 from both sides. Number 9, it looks like it's so hard, but you just do what you can. You do little pieces and bits and pieces here and there until you can figure out the whole problem. Okay, so we're given different things. We're given this is 55 and that's 60. Well, this is half of a circle, so that's 115 total, which means that there's 65 left for that. And then this whole other side is 180, so we know that. So let's first figure out, well, whatever you want, really. Let's take a look at x first. So the angle x is equal to the big arc, which is 180, plus 65, the smaller arc over 2. So that is 245 over 2, which is 222.5. Okay, y is, it's just going to be y equals, sorry, not y equals, it's the angle, 70, equals the big arc, which in this case is half of a circle, 180, minus the little arc, which is what we don't know, over 2. I get 140 equals 180 minus y, and so, pretty easily there you can figure out 180 take away what is 40, so y equals 40. Alright, let's take a look at what's next. Alright, so here we have 3 variables. We have a circle inscribed inside a triangle. Let's take a look what we can do here. This is 130, this is 152, so just based on what we know out of a circle, we know this is 360 minus 152 minus 130, and that gives us 78 for this other arc over here. That's important. And now we can just figure out the angles one at a time. Let's start with x. X is the angle. It equals the big arc. Well, the big arc here are these two put together. So 282 minus the little arc, which is 78, all over 2. So 282 minus 78 is 204, and 204 divided by 2 is 102. So x equals 102. Y is same exact setup, just different numbers. Y equals, we have 72 and 78 and 152. Put those together as the big arc. That's 230 minus 130 all over 2. And so y equals 50. And then I'm not even going to do a calculation using circles for z. This is a triangle. Triangles have to add up to 180 degrees. Their angles do. And so 102 plus 50 is 152. So all that's left for z as far as angle measure is 28 degrees. 180 minus 102 minus 50. Okay? Alright, let's take a look here. What is the length of the radius? Okay, find the length of the radius. So I'm going to label the radius as r. The setup here is what is difficult for us sometimes. So we'll say we have this. If this is a tangent and that's the radius, we know it's a right angle. Okay, we have a right triangle, so I'm going to use Pythagorean theorem. Alright, we have r squared plus 14 squared equals r plus 9 squared. Now you got to know how to FOIL or use the grid method or vertical or whatever, but you're going to have to be able to square a binomial. This becomes r squared plus 196 equals r squared plus 18r plus 81. Okay, I'm going to subtract r squared from both sides, and I have 196 equals 18r plus 81. And then 81, subtract that from both sides, and I have 115 equals 18r, and 115 divided by 18 is 6.4. So the radius here is 6.4. Okay? Point. Number 12. We have, again, not same kind of problem. Let's set it up. We have 6 squared plus 8 squared equals, this is like r plus x squared, but we know the radius is 6, so you can do one of two things. You can say 6 plus x squared, or you could introduce a third variable. Some people like to introduce a third variable right here, and they call this whole thing, you know, q. And what you do then is, instead of having a binomial in there, you just do 6 squared plus 8 squared equals q squared. We end up doing Pythagorean theorem and we get q squared equals 100, so q equals 10. Well, if the whole thing is 10, and this part is, this radius here is 6, then x equals 10 minus 6, which is 4. Okay? Here we go with another circle triangle problem. We'll start with x. We'll start with y, actually. Let's do this. Let's just write them all down. Starting to lose it. If this is 32, then y has to be 180 minus 32, so that's 148. Okay, 148 is being being intercepted by this angle. So if the vertex is on the circle, then the angle is half the arc. The arc is 148, so x equals 74. And here z is intersecting, I'll draw it for you, it's intersecting a semicircle. If an angle is intersecting a semicircle, half the circle is 180, so the angle has to be half of that, which is 90. Alright, let's take a look at this one down here. If this is 41, let's write our angles out again. X equals, y equals, and z equals. You know, you go in whatever order is easiest for you. I mean, when you look at the circle, this is half a circle, so x equals 139. You know, it's 139 and 41 have got to add up to 180 degrees. Y creates the arc that is x, so y has to be half of 139, which is 69.5. Z has to be half of 41 because its angle is here and it's intercepting that 41 right there, so that's 20.5. You know, these problems look complicated, but if you know the rules and know the formulas, they're not. But you got to know your stuff. Here, so here we have, this is 35. So if this is 35, then this is 35. And x is this angle right here. So that's a straight line. So that's 180 minus 35, which is 145. Y and Z both intercept the same angle and both have vertices that are on the circle. So the angles Y and Z are the same. They're both half the arc, which is 17.5 degrees. Again, not a lot of real complicated math, but you got to know your stuff. In the circle below, the measure of angle A is 93 degrees. All right. The measure of AC, arc AC, is 100, which makes this 50, which makes this 50, because they're marked congruent. Now I'm looking for the measure of angle C and the measure of arc AB. So the measure of angle C, a quadrilateral inside a circle, these opposite angles here are supplementary. So 180 minus 93 gives us 87, so that one's easy. If this is 87, the arc that it's intercepting is this arc right here, this arc from D to B. Well, if this is 87, then DB, the measure of arc DB, is double 87, so that is 174. 50 of it is right here, so all that's left over here for AB is 124 degrees. Again, the math there is not real complicated, but I know my stuff. Okay. Here, this is product of the pieces. So this is 6 times 10, which is 60, equals 15 times x, so x is 4. Here we're looking for the length of the radius. So we did these in class. We're going to find this missing piece here, then add 5 to it, and then cut it in half. So 10 squared is 100, equals 5 times x, so x equals 20. So the diameter is 25. So the radius is half of that, which is 12.5. Find the value of y. This is outside times the whole thing equals outside times the whole thing. So 4 times 25 equals y times y plus 15. So we end up with 100 equals y squared minus 15y. We're going to have to factor, which means I have to get it equal to 0. So y squared minus 15y minus 100. So then I'm looking for two numbers that multiply to negative 100 equals, and add to negative 25. That's y. That's y. This is minus 20, and that's plus 5. I've done these a lot. Y equals 20 or negative 5, and I know that y can't be negative. Okay. It can't be negative, so this can't be an answer. So y equals 20, because it's a distance. Distance can't be negative. Length, whatever. Here we have z squared equals 9 times 20. So z squared equals 180. So the square root of 180 is 13.4. All right. Find the perimeter of the pentagon. This is where we work our way around the outside. So if that's 2, that's 2, which makes that 2, which makes that 5, which makes that 5. This part I don't know, but that's 2, that's 3, that's 3, that's 5. So this is 5 also. So then I'm going to write my sides separately over here so I don't get confused. I know one side is 5, I know one side is 8, this side down here is 10, this side is 7, and this side up here was 4. Okay. And pause that. Hope you weren't writing down too fast, because we have our first mistake on a video. Psych. I made a million mistakes. I just don't tell you guys. This is 2. I started here with this being 2, and that should have struck you right away. That's wrong. So if this is 2, this is 2. Then we have 3 here. That becomes 3. This becomes 5, and this becomes 5. This problem, I like this problem, which is why I wish I didn't mess it up the first time. I don't know what this side is. I know it's congruent to this piece right here. I also don't know what this is. I just know that it's equal to that right there. Now, red plus blue makes 7. So I can pick any numbers I want for these red and blue, because I'm not asking you for specific parts, or the question's not asking us for specific parts. The question's asking us for the perimeter. If this is 4, then this is 4, and that's 3, and that's 3. As long as blue plus red makes 7, I'm good. I typically just do this because it saves me time. I make one 7 and one 0. But as long as those parts add up to the sum that they are supposed to, it doesn't matter what numbers you choose. If you want to choose 6 and 1, fantastic. 5 and 2, even better. 3 and 4, that's weird. Anyways, as long as these two parts add up to the same as this side of the pentagon, you're good to go. So, let's try this again. The sides are 5, 8. 5 plus 0 is 5. This side is 7, and that side is 9. So there's my 9 sides, or my 9 sides, good gosh. My 5 sides, so 18 plus 16 is 34, so the perimeter is 34. Okay, define the following or give the formula. I'm leaving those blank. You're on your own for those. Look something up, use the internet, use a book, use your notes, do something. You need to be able to define those terms though. What is a chord? What is a tangent? How do you find the diameter? Give us something, okay? Look it up. Have a blast. The internet is out there. On this one, you know, it asks me for all this information. I'm going to label everything I know. So if this is 125, I know this is 55. I also know this is 55 because of this diameter. Those two are congruent, so that's 55. If this is 110, which that's what they add up to, then all that's left for this is 70. So now let's see what I have. DA, that's 55. AEC, so arc A to E to C, so that's 180 degrees plus 55 is 235. Arc DC is right there, that's 70. And CAE, so from C to A to E, so 70 plus 55 is 125 is 250, so 250. C to A to E. Alright, slope, distance, and midpoint. Hopefully at this point you're just a professional at these. The slope here, I always, you guys know from other videos, I'm always going to sketch it just so I know positive and negative. So this is 3 over 6, which reduces to 1/2, and it's positive. The distance is the square root of the change in the x's, which is 6, squared is 36. The change in the y's, which is 3, squared is 9. So the distance is the square root of 45, or 3 times the square root of 5, or you can calculate it and put it as decimal. Midpoint is average. -2 plus 4 is 2. Divided by 2 is 1. 3 plus 6 is 9. Divided by 2 is 4.5. Okay. Nap time is over. It's about to get noisy. Write the equation of a line parallel to this through that point. So we write, I'm going to use the y that I'm given, 5 equals, the slope is parallel, so it's the same. So -2 times -1 plus b. We end up getting b equal to, this is -2 times -1 is 2. Subtract 2 from both sides and you get b equals 3. So parallel means y equals -2x, same slope, plus 3. Perpendicular is the same problem except for the slope is now the opposite reciprocal. So I use my y that I'm given, 5 equals the opposite reciprocal slope times x plus b. So this is 5 equals 1/2 plus b. b equals 4.5 or 4.5 or whatever. So y equals -1/2 x plus 4.1/2. Okay. Let's take a look at this last page. This is a throwback. It's not even Thursday. You got to know these angle pairs. These are corresponding angles, same location, different intersections, so they're congruent. I know I showed my students to use like this checkerboard pattern here to make sure you remember what's equal to what. So if you can color your paper, which some of you are really, really good at, you can color your paper like that. Same color, same measure. Different color, supplementary. Really simple process. So 4x equals 10x minus 24. We get -6x equals -24, so x equals 4. These two, if you do the coloring assignment, become supplementary. They don't become supplementary, they are supplementary. So 3x plus 2 plus 2x plus 20 equals 180. So we have 5x plus 22 equals 180. 5x equals 158. And so x equals, let's make sure we do our math right, 158 divided by 5, 31.6. Okay. Let's define some of these pairs. In the picture below, use the information to classify the following angles and state what you know about their measures. So 1 and 5 are corresponding, and they are congruent. 3 and 5 are alternate interior, and they are congruent. 4 and 5 are same side interior. I'll write that out for you, not for me, for you. Same side interior, you'll also see consecutive sometimes. Interior or consecutive. And they are supplementary. Whew, handwriting's getting bad. 6 and 8 are vertical angles, and they are congruent. 1 and 7 are alternate exterior, and they are congruent. And 1 and 6 are nothing, and I don't know nada. In the figure used for question 1, what is the vocab we learned for line L? Those are two lines being cut by what's called a transversal. Okay, knowing the words is important. Here again, you know, if you do the color thing, those two don't have the same color. One's white and one's orangey, so they are supplementary. 10x minus 3 plus 8x plus 21 equals 180. 18x equals, let's see, that's 18, subtract 18, 162. So x equals 9. You like that math in my head. That's it, guys. That's the review. That was a long time. My hand hurts. You know, you got to study. You got to come prepared. Hopefully you do well. Hopefully you watch the parts of the video that you need or like or want or whatever. All right? See you when the snow's done. Deuces.